In this video, we're continuing section 1.3 on logical equivalences, and we are going to do some more logical equivalence examples. Okay, all right, so for this example, I want to show P implies Q and Q implies P is equivalent to P if and only if Q. So first off, just using a little bit of intuition, what the left-hand side is saying is, two things are happening because I have an and statement. It's saying, well, if P, then Q, and it's saying if Q, then P. In other words, this is saying both directions are happening. So I think it makes sense that that should be the same as P if and only if Q. So we want to show this using a truth table. Okay, so I'll write my P and my Q, and then I'm going to build up to each side of this. So on the left-hand side, I think I'd first want to figure out what P implies Q is. Then I'd want to figure out what Q implies P is. And once I have those, I can put them together to do P implies Q and Q implies P. Okay. All right, I'm just going to start this and just see what else I might need. So I'm going to separate out those initial ones. Here's the final one I'm building up to. So I'll put another vertical line here. Okay, and then all my intermediate steps that lead up to this final one, I won't necessarily separate those with another vertical line. Although if you wanted to, we could. Even if we wanted to put another vertical line here, we could. But I just like to put vertical lines when I separate out these initial building block propositions and right before I get to the final one I'm trying to build. And then for the right-hand side, well, I think once we have the P and the Q, I'm ready to build the right-hand side right away. So I'm going to put another vertical line. And then I think we can build the P if and only if Q right away. Okay, so Q could be true, false, true, false. I alternate those. And then P will be double trues, double falses. As we've seen before in the previous videos, when we do it this way, it makes sure that we have all the possibilities. Okay, so now I need to do P implies Q. Remember, that implication could only be false if the first part is true and the second part is false. So that happens here. First part is true, second part is false. So that makes it false. The other situations make it true. So true, true, true. Okay, for Q implies P, I need Q to be true and P to be false. Where does that happen? Where Q is true and P is false. Here, Q is true, P is false. So that is where it's going to be false. There's no other row where that happens, where Q is true and P is false. So the others are going to be true. So true, true, true. Now I'm ready to combine these two columns with an AND statement. And we've seen that with an AND statement, what it takes for it to be true is both parts have to be true. So this has to be true and that's got to be true. So that's happening in this top row. It's happening in the bottom row. But in the other rows, at least one of them is false. And that makes the AND statement false. Okay. All right, so now I know the truth values of the left-hand side. For the right-hand side, we just got to remember, well, how do I get the truth values of a biconditional? A biconditional is true when the truth values of P and Q are the same. So that happens if they're both true. They're also the same if they're both false. But if they're different, if one is true and the other is false, that makes the biconditional be false. Okay, so now I compare these truth values. So here's the truth values of the left side. Here's the truth values of the right side. Those are exactly the same, which means that these are equivalent. They're equivalent since their truth table outputs, are the same. All right, let's look at another example. For this next one, I want to show that P implies Q is equivalent to not P or Q. So for this one, I want to give you an opportunity to try this on your own first. So take maybe 2 minutes to pause the video, see if you can draw a truth table for this one to show that these are the same. Pause it in 4, 3, 2, 1, pause it, and try this one. All right, so hopefully you did that. Hopefully you paused it and tried it. If not, definitely go ahead and do that now. These times when I give you a chance to try these problems, this is actually the most important part of the video because there's a difference between watching me do examples and being able to practice it and doing it yourself. That practice is ultimately what's going to make the most impact in terms of you learning this stuff. So definitely take advantage of those times to practice it. Okay, so let's go over it. So I have a P and a Q, and I think once I have those, I'm ready to just go straight to the conditional. So I can go straight to that. To get the one on the right-hand side, I think I'll need the not P first. And then once I have not P, I can combine that with a Q to build my not P or Q. Okay, so I'll have my horizontal line, separating out those building block ones, separate out, here's one of the major ones. And then before I get to the other major one, I'll separate that out as well. Okay, so for Q, I alternate true, false, true, false. For P, I'll alternate double true, double false. And now I have all four possibilities here. Just like we saw in the last one, P implies Q is only going to be false if P is true, but Q is false. But in the other rows, the conditional is true. Okay, so I'm hoping that this column and this column are going to match. Okay, so I need to get not P next. So that's going to negate all of the truth values of P. So I will have false, false, and then true, true. Now I have to combine the not P column and the Q column with an OR statement. And in an OR statement, what it takes for it to be true is at least one of them's got to be true. So that's happening in the top row, because in the top row, this one's true. In the next row, well, both of them are false. So that makes it false. That makes it false. And the next row, actually, they're both true. And in the last row, one of them is true. Okay, so that is enough to make both of those columns true. So if I compare here's my left-hand side, here's my right-hand side, well, those are the same. Those are the same truth table outputs. So as a result, P implies Q is indeed equivalent to not P or Q. Okay, so we've shown this using truth tables. Let's just convince ourselves that this is the case using a little bit of logic too and intuition. What if I was looking at a if-then statement like this? If it's Wednesday, then I wear pink. So the hypothesis, the if part, is that it's Wednesday. That's the P. And the conclusion is the I wear pink part. That's going to be Q. Well, I can think of this as a rule. If it's Wednesday, I wear pink. And this rule is violated precisely when it's Wednesday, and I don't wear pink. If it's a Wednesday and I'm not wearing pink, then I've broken or I've violated this rule. In other words, what's happening is for me to violate it, I need P to be true, and I need Q to be false. I need the conclusion to be false. That's the only way to violate this rule. So that's equivalent to saying, well, this rule is satisfied or it's true when this doesn't happen. So I'm violating it if it's Wednesday and I don't wear pink. So that means it's going to be true if it's not Wednesday. If it's not Wednesday, I'm in the clear. Or if I wear pink. Because if I'm wearing pink, I'm going to be good no matter what. Because if it's Wednesday, I'm all good. But if it's any other day, there's no, I could wear whatever I want. So if I wear pink, I'm safe. And also, if it's not Wednesday, I'm safe. I could wear whatever I want. So another way to say this is, well, it's going to be satisfied. This if-then statement is going to be satisfied if the P is false. So if it's not Wednesday, all bets are off. I could wear whatever I want. So if P is false, there's no way to violate the rule. It's also going to be good if my conclusion is true. Because if I'm doing whatever the conclusion says I need to be that I need to be doing, then whether it's Wednesday or it's not Wednesday, I'm going to be good no matter what. Okay, and that's precisely what this is saying here. This is saying that, my if-then statement should be equivalent to not P, which is what we're saying here, P is false, or Q, which is what we're saying here. So this is kind of like a logical intuition.